Okay, in this video we're going to start the process of solving the wave equation. We're going to separate the PDE into two ODEs. Okay, so let's start with our assumption. U of xt is a product of a function of x times a function of t. And our differential equation is a squared second derivative of u with respect to x equals second derivative of u with respect to t. Okay, write each of these derivatives in terms of capital X and capital T. Capital X, second derivative. Capital T, second derivative. We want to divide by a squared t and x. So that we have just the highest order derivatives left in the numerator. So we have x double prime divided by x equals t double prime divided by a squared t. Both of those are going to be equal to a constant, so we'll call it minus lambda. So we have x double prime over x equals minus lambda, which means x double prime plus lambda x equals 0. We have t double prime over a squared t is equal to minus lambda, which means t double prime plus lambda a squared t is equal to 0. Okay, we need to look at our initial conditions. So those two are done for now. Let's see, plugging in 0 for x. So our u of 0t equals 0 tells us that x of 0, t of t equals 0. So either x of 0 is 0 or t of t is 0. If capital T is always 0, that means u of any xt is equal to 0, which is the trivial case. So we're going to assume that x of 0 is 0. Let's see, other initial condition, u of lt is equal to 0, which means capital X of L, capital T of t is equal to 0. So either capital X of L is 0 or capital T of t is 0. Okay, again, this is going to be a trivial case. And so we're going to assume x of L is 0. So these two along with this is going to give us a differential equation, second order, with two boundary conditions. So we should be able to solve for eigenvalues lambda and corresponding solutions, eigenfunctions x. The other differential or the other boundary condition I'm probably not going to mess with. It's not actually going to tell me anything since it's not something equal to 0. So I'll just leave that one alone. Okay, so we've successfully separated. Like I said, we're probably going to focus on this x differential equation and the two x boundary conditions in order to solve for lambda.